This lesson is going to be on partial variation. Partial variation is the linear relationship between two variables where the dependent variable is the sum of a constant number and a constant multiple of the independent variable. Now what this means is that as opposed to starting from 0, 0 on my graph, now I'm going to start from someplace on the y-axis. So the y-axis is the axis that goes up and down. So right here, that's my y-axis. Going this way, horizontally, is my x. So let's say we have some sort of situation where we have some fixed cost or fixed number to start with, like a taxi cab. If you have to take a taxi cab, you have a fixed cost of $4 as soon as you get into the cab, and another 50 cents or $0.50 per kilometer. So it's $4 to step into the cab, and then it's 50 cents for every kilometer thereafter. So here my dependent variable is going to be the cost, so C, and my independent variable, because it doesn't matter, cost doesn't matter according to my distance, kilometers down here. So I have 0, 1, 2, 3, 4, 5 kilometers, and going this way I have 1, 3, 4, 2, 5, 6, 7, 8, and 9. So I've costed $9. So right away, starting off, before I even move 1 inch, it's cost me $4. So that's where I start. And after 1 kilometer, here, I'm already up to $4.50. At 2 kilometers, I'm now at $5, $5.50, and then at 4 kilometers, I'm now at $6. So I still have this kind of constant multiple, but I've just changed now where I started on the y-axis. So now I'm no longer starting at 0, 0. Now I'm starting at 0 and 4. So it's cost me $4 already to step into this cab. And I can just draw a nice linear relationship like that. Now, this has the fixed cost right here, fixed cost or constant, and here is my constant variation or constant multiple. And these are two very, very important terms because they fit into what's known as my linear equation. And my linear equation is y equals mx plus b. Y is my dependent variable. X is my independent. And these can be anything. It could be money, it could be time, it could be lots of different things. So these are just my variables. Now in this case, m, that's my constant multiple. And b is my fixed constant. So I have this general equation that I can then solve for any values of x and y as long as I know two things: my constant multiple and my fixed constant. So my m and my b. So let's take this for example. I have a small pizza and it costs $7 per topping plus 50 cents for each additional topping. In this case, my fixed cost, my b, is $7. And my m, or my constant multiple, is 50 cents. So I can put this into my y equals mx plus b equation. So I'm not sure what y is yet. I'm not sure how much anything costs, because I know it cost me 50 cents, but I'm not sure times what. So I'm not sure x. But I do know, no matter what, I can start at $7. So my question is, how much would a pizza with 5 toppings cost? So I know it costs 50 cents per topping plus another $7. So I take this equation and I just sub in 5 for my x value, because 5 toppings is my or independent variable. So how much will this cost? So y is equal to 0.5 times 5 toppings plus $7. 0.5 times 5, y equals $2.50 plus $7, and I get a grand total of y equals $9.50. So my pizza will cost me $9.50 if I put 5 toppings on it. And from this general equation, I can figure out if it costs more or less with more toppings, 7, 8, 9, 10 toppings, or less, 3 toppings, 2 toppings, no toppings. No toppings, it'll just cost me $7. So from this partial variation, which I can then transform into my linear equation, I can find out all sorts of information for any type of relationship where I both have a fixed cost and a constant multiple.